Hey y'all. Today's lesson is about solving a system of equations by substitution. We've already gone over how to solve a system of equations by graphing, and so here's another method to solve a system of equations. A system of equations is two linear equations, and the solution is an ordered pair. The solution is an ordered pair. The substitution method states that to solve it, you have to replace one variable with another. Substitution means to replace, like in a game, if you need a sub, then one person goes out, another player comes in and replaces them. Same thing in math. We want to make sure that when we use substitution, our answers are exact, or our values are exact. We're not going to be rounding. We're going to keep them exact. And here are a few steps. The first one is you need to solve for one variable, either the x or the y, and I'll show you how to do that. Second, once you solve for the x or y, you're going to substitute it into the other equation. When you have a system of equations, you have two equations. So we're going to solve one and then plug it into the other one. You're going to solve it, solve for the variable, either x or y, and then you have to replace it again because it's an ordered pair. So our solution is to have an x value and a y value. So you're going to end up solving it for the x equals and then plugging that in to find y equals, or vice versa. Solving for y equals, plugging that in for x equals. So I'm going to show you the examples that we have on your note guide. All right, so example 1, system of equations, y equals 2x, negative x plus y equals 5. Now, if this were graphing, then you would have to solve for y and graph them and find the intersection, but here's another method called substitution. Both of these examples already have an x equals or a y equals, so it's going to be a little bit easier for us. This equation right here is already in the form y equals, so we're going to start with that equation and we're going to substitute it into the y for this second equation. Since it's already in y equals, it's easy for us to substitute it. It's exact. Y equals 2x. Y equals 2x. So then I can rewrite it. Instead of writing y, I'm going to rewrite it as 2x. Because y is equal to 2x. I'm substituting in. I'm taking out the y and I'm substituting in 2x. Now I can combine like terms and I get x equals 5. That was simple. X equals 5. So that was step 2, substitute it in, and step 3, solve. Now step 4 says we have to replace it. I found the x, so I know my answer is going to be x comma something. But in order for me to find the answer, I'm going to replace it back up here. So y is equal to 2 times x, so y is equal to 10. Now, you could replace it here for sure. That's fine. I just think this one's easier. And I rarely tell you to do the easier thing, so for this problem, do the easier one. All right, example B, I have an x equals right here. It's already solved for x equals, so let's use it. I need to substitute this exact value, because this is an exact value, into x right there. There is no coefficient right here. If there was a coefficient, like the 8 in front of the y, then I would put it in parentheses. But there's no coefficient, so I'm going to rewrite x. But I'm not going to write x. I'm going to write what x is equal to. 2y minus 4, that is equal to x. We're substituting it in. Plus 8y equals 16. Now, here's a key when you're rewriting it. You always want to make sure that one of your variables is not there anymore. If you rewrite the equation and you still have x's and y's, then you've done something wrong, or you need to resubstitute, because one of your variables should go away. Now we can solve. We can combine like terms. So that's 10y minus 4 equals 6. We're going to add 4 to both sides. 10y equals 10. And then divide both sides by 10, and y equals 1. That says 16. Sorry. Okay, plus 4, and that would be 20. And then y equals 2. Sorry, I wrote 6 instead of 16. So y equals 2. Now I found part of my ordered pair. Now I need to go to step 4 and I need to replace it. I'm going to go back up here and I'm going to replace it into this equation. X equals 2 times y, and y is 2. So 2 times y minus 4, and 0 minus 4 2 times 2 is 4. 4 minus 4 is 0. So x equals 0. Now I have an x value and a y value, so my ordered pair is 0, 2. Now, of course, you want to check these. I'm not taking the time right now in your notes to teach you and show you how to check. You plug both of these in and you see if they work. But remember, you can always check your ordered pairs by plugging in the ordered pair and making sure that it works, or graphing these equations and looking at the intersection. All right, example 2. Solve the system of equations by substitution. These examples are in the standard form, so we need to solve for an x or y. These are not solved yet. I'm getting another color marker. Sorry, I'm going to get another color. These are not x equals y equals. So you don't have to always do y equals like slope-intercept form. I'm telling you to choose the easiest one. When you look at the equations, one hopefully will look easier. So in example A, I have 4y minus 5x equals 9 and x minus 4y equals 11. Well, I think this one looks easier because the x doesn't have a coefficient, which means I won't have to divide. Look for the one where you see a variable without a coefficient. I want to solve for x equals, so I'm going to add 4y to both sides. And x equals 11 plus 4y. Now I have an x equals, and I can take this, and I want to substitute it into the other x right there. You don't want to substitute it back in here because then everything's going to cancel out. You're not going to substitute it back into the same equation you just got it from. You're going to substitute it into the other equation. So 4y minus 5. Now because I have a coefficient of 5, I'm going to use parentheses. 11 plus 4y equals 9. You need to distribute. So now you remember we did multi-step equations with distributive property and combining like terms. So we need to distribute. Negative 55, negative 20y equals 9. I can combine like terms. And that is negative 16y minus 55 equals 9. I'm going to add 55 to both sides, and I get 64. And I'm going to divide both sides by negative 16, and y is equal to negative 4. Divided both sides by negative 16, and y is equal to negative 4. That long process was the part only half of my ordered pair. Now that I found the y, I have to plug that back in to find the x. I'm going to come back up here to my circle, and x is equal to 11 plus 4 and times y, and y is negative 4. So 11 plus negative 16. So x is equal to negative 5. I substituted my y value back into my circled equation, and now I can write my ordered pair as negative 5, negative 4. Just remember, a common mistake is students will flip-flop. Whichever answer they find first, they'll put that in. Even if in this case it's the y, they'll put that in the first one and they'll get it wrong. So be careful, pay attention to if it's your x value or your y value. All right, example B, we have to solve one of these for either x equals or y equals. And when I'm just looking at it, I see that this y right here doesn't have a coefficient. So I'm going to solve this one for y equals. It has the negative right there, so negative y, and I would do minus 3x is going to be 18 minus 3x. Or if you're used to doing slope-intercept form, put negative 3x plus 18. And then I would need to divide by negative 1. So y is equal to a negative 18 plus 3x. So that is my y. I have solved for y equals. And I'm going to substitute this in for my y right here. 5x minus 4. Now because I have a coefficient, I need parentheses. Negative 18 plus 3x equals 23. Just a quick check. I only have x's. I don't have any y's, and so I've substituted correctly. If you ever have y's left, or if you have two variables left, you've probably done something wrong. I have to distribute 5x plus, let me see, 72 minus 12x. You're going to combine like terms, so negative 7x plus 72 equals 23. I'm going to subtract 72 from both sides, and I get negative 49. And then I divide both sides by negative 7, and x is equal to 7. That's half of my ordered pair. I found the x value. I need to substitute it back up here to find the y value. Negative 18 plus 3 times 7. Negative 18 plus 21. So y equals 3. Then you put it together to find your ordered pair. And for this, my ordered pair would be 7, 3. Again, you want to check. I am just not using the time right now to check because these problems take a long time. All right, so some special cases that you have. Here are two problems that are special cases that I'm going to go through. When I say special cases, that means it's either going to be infinitely many or no solutions. So infinitely many solutions or no solutions. For problem A, I already have a y equals, so I'm going to substitute it in. We'll start to recognize, oh, it's already y equals, let's substitute it in. 5x minus 2, substitute all that in, distribute, so that is going to actually be, the 2's are going to cancel, so negative 5x, and this is a negative and a negative, so plus 10. 5x minus 5x, when I combine like terms, those cancel, that's 0. So then I'm just left with 10 equals 10. That solution is true all the time. So this would be an infinitely many solutions. There's not just one ordered pair. What this is saying is this is going to be the same line. If you were to graph the top one and the bottom one, you end up getting one line, and the system of equations is the same line. So every solution on that line works. Still, by substitution, you still come get to 10 equals 10. In this problem over here, I need to solve. I'm just going to solve for y equals. I'm going to divide by 5. And y equals 2/5 x. I just solved it because this one had more numbers. So I just thought you could have divided by 2 and solved for x. I have to substitute that in for y. Equals negative 24. 2x minus 5 times 2/5 is going to cancel out to be 2. So minus 2x equals negative 24. 2x minus 2x is going to be 0. And does 0 equal negative 24? The answer is no, it doesn't. Not ever. So this would be no solutions, which means that is a set of parallel lines. No solutions means the lines run parallel and they never intersect. So there's no ordered pair to make that system of equations true. All right, last one. Have a you try. All right. Solve the system of equations by substitution. I want you to try it at home, and then we will check and see what you get. So this one's already solved for y, so substitute that into y and come out with your ordered pair. All right, bye.